How do you find the area of a parallelogram? In this video, we'll discuss how to find the area of a parallelogram. And I just want to remind you that this is from the title at the top of your note should say 10-1, areas of parallelograms and triangles. And this is a section from your textbook. Okay, here is a reminder of how your notes should be set up for the second semester of us taking notes from videos. Your video title, not the video title, but the section from your textbook or whatever section we're going over in class is at top. This is the video title number 1, and there's only one video title for this section. So you're going to go ahead and write down the video title here as your question. You'll create your notes, which actually answer that question. And then once you review your notes and review the question that's being asked, you'll go ahead and answer the question through a summary that should be 3 to 4 sentences in length. Any questions about how to do your notes, please ask me in class. Okay, so just a reminder that this is 10-1, area of parallelograms and rectangles. Sorry, I said triangles, but it's really rectangles. And so we're going to start off with theorem 10.1. What is the area of a rectangle? Well, the area of a rectangle is the product of its base and height. Product means to multiply. So we're going to multiply the base times height. Here's the base of the rectangle and the height of the rectangle. When you multiply those two numbers together, you will get the area of the rectangle. And the same formula, I want you to notice that the same formula is being used for area of a parallelogram. It is also base times height. And you might be thinking, well, why is it the same when the shapes don't even look the same? We're going to prove that why they are the same exact formula in class. But for the area of parallelogram that I'm going to focus on for this video, you have a parallelogram, you're given the height and the base just like you do for a rectangle, and you multiply those two together and it'll give you the area of the parallelogram. During first semester, we learned what a parallelogram was, and I'll just go ahead and review quickly for you what a parallelogram is. It is a quadrilateral, which means that's 4 sides, with 2 pairs of parallel sides. So notice that this side is parallel to this side, and this side is parallel to this side. The opposite or facing sides of a parallelogram are equal in length. So this side is equal to this side, and this side is equal to this side. And the opposite angles of a parallelogram are also of equal measure. So this is opposite angles here are equal, congruent, and so are these two angles here. Now, if we look at a parallelogram with a base of a parallelogram is any of its sides. So any of the sides can be the base of the parallelogram. You just want to go ahead and make sure that you have labeled what the base is. The corresponding altitude, so it has to be the corresponding altitude, is a segment perpendicular to the line containing that base. So once you have chosen your base, then you can create your altitude. So if you choose this as your base, then your altitude is going to be perpendicular. That means it creates a 90-degree angle with the base. Excuse me, my allergies are really bad. And what happens if you choose another side? If you choose this side to be the base of the parallelogram, that's okay. You just got to make sure you find a line that's perpendicular to it. And so this would be the best line. And sometimes the altitude will be on the outside of the figure instead of on the inside. The height is the length of an altitude. Okay, so the altitude is also the height. So I'm saying a lot of things. You want to go ahead and write some extra notes like this is the height. Altitude is also the height. Notice that altitude could be on the outside or the inside. And you get to choose your base. But depending on how you choose your base, that's where it's going to tell you where your altitude is at. So let's take a look at these two examples down here. I'd like you to pause the video and then resume when you're ready to follow along because I'm going to explain a few things. Okay, I'll assume that you have copied down all the information from the slide and you're ready to follow along. Let's look at example A. We're given a parallelogram. How do we know? Well, it has 2 sides that are opposite, that are congruent, and also 2 pairs of parallel sides. And notice that we've chosen the 5 to be our base. So you can write down here, this is our base. So if that's our base, then this is going to be our height or our altitude. So I'll put an H next to it. And now we're going to use our formula, which is area equals base times height. I plug in the 5 for the base. I plug in the 4 for the height, and I multiply, and my answer is 20. So the area is 20 inches squared. And then let's take a look at example B. I have my base, which I chose to be 2, but if I'm going to draw a line perpendicular to it, The best one is right here. And so this is going to be our base for 2. Oops. I did not mean to write A. Let me erase that. Okay. This is going to be our base, B, and then this will be then our height. So we plug it in. B is 2. Height is 3.5. Multiply that. We get 7 as our final answer. So 7 centimeters squared for the area. Notice that I keep using squared. It's because I'm multiplying two numbers. And we're talking about the area. So area is always going to have the inches squared or centimeters squared. Now I'd like you to go ahead and practice on your own. But this time you have to draw the picture. Go ahead and do example 1 on your own and bring your questions to class. Okay, the last 2 examples, part A and B, were very simple. They gave us the figure, they gave us the heights and the bases. Well, now we're going to need to find some missing dimensions. So this is not just a basic find the area problem. It's use the area to help you find some other measurements of the shape. So let's take a look at what we have. For this parallelogram A, B, C, D, they want us to find what CF is. So I'm going to go ahead and label CF as X because that's what I'm really looking for. Notice how I did that at the very beginning of the problem. And now we're going to find the area. We're going to first find the area of this shape. And then we're going to use the area to help us find out what CF is. I'm going to use the area. I'm going to use 10 as my base. My height is going to be 12. And once I plug that in, I get 120 as my area. Now, does that help me solve for what X is? Well, it doesn't. But if I rotate this figure over onto its side and make 13 the new base, then I can use this X as my new height. I'll put a little H there. And now I can go ahead and find out what the CF is, since I have my new height, which is the altitude. Now, the reason why I needed the area is because it's the same area. No matter, I'll use red. If this is my altitude or if this is my altitude, the parallelogram still will have the same exact area. So now I'm going to use A equals B multiplied by H. We know that A is going to be 120 because we're using the same parallelogram. We know that the base, our new base, is 13. So I'll put 13 there, and that's from here. And then now the height is going to be this X, and I don't know what it is, so I'll just label it as X. And then I can use my calculator or some basic division and figure out what X is. Divide both sides by 13. So 120 divided by 13 is, and it says rounded to the nearest tenth. See how I always notice that? Because I know I have a decimal answer. Should be 9.2. So X would be 9.2 or CF would be 9.2. Okay, so notice that this one we didn't have to just find the area, but we had to use the area to find out another missing altitude or a missing height. And now I'd like you to try this number 2 on your own. It's the same type of problem that we did for the example. Okay, to conclude this video, I want to give you a real-world connection. This is using the front of a garage, and you're trying to find the area of that. So go ahead and use all the area formulas that you know of to find the area of this front of the garage. We're going to discuss this example in class and practice it, but I thought I'd give you an opportunity to practice it beforehand. Bring all questions from this video to class, and we'll discuss them together.